In this video, we are going to continue our research into data collection, and we have three objectives today. First of all, be able to differentiate between population versus sample. Be able to know and identify the various sampling methods. There are about, I think there are 8 of them that we will discuss. And lastly, identify sources of bias within a particular example. All right, to address our first learning objective, you'll notice how we've got it cut up into top and bottom. Well, we've already discussed some of these. What is a census? I'm wondering basically if you remember that vocabulary from last week. A census is conducted census occurs when all individuals are checked for whatever it is that we're interested in. Whatever variable we're interested in, that's what we would look at. For instance, if we wanted to know how many points people have on their driver's license against their driver's license, we would have to look at every single driver's license, every single person with a driver's license in the entire state to conduct a census. Well, population and parameter are related to a census. Population is the entire group. In that example we just mentioned of if we were going to check the points against a person's driver's license, we would have to check every single driver in the entire state. Well, that group of all drivers, that's the population. Whatever variable we're interested in, we're eventually going to go get a number. Last week we had examples that were talking about like the average number of cars that a person owns, or the average number of guns that they own, the average number of kids, their average age, average height. We used a lot with average because, frankly, average is pretty easy to calculate. We could use mean, we could use median, we could use any of those centers of tendency, but when we do that, when we actually crunch the numbers, the thing you get is called a parameter. So as an example, if we were to use the average number of kids, it would have to be the average for the entire population. Every single person in the population has to be checked in the census. When you crunch the numbers for your census, you will get the parameter. The other three things, sampling, sample, and statistic, same thing, but it's not the entire group. Sampling is done when only part of the group is checked. So maybe you check 10%, maybe you check 20, maybe it's 30, but it's not the full population, it's not 100%. That portion that gets checked is called the sample. The part or the portion of the population that gets checked is a sample. And a statistic, please note how important this is because the class is called probability and statistics. Well, this is what statistics are all about. A statistic is data that's calculated from a sample. A parameter is data that's calculated from the population. Now, if we wanted to know the average number of kids that people have in the entire country, do you feel like checking all 320 million people? How difficult would it be to go check all 320 million people? How many billions of dollars would it cost? By the way, it costs about $12 billion to do it. And the United States government does it once every 10 years. It's called the census. By federal law, it's actually within the Constitution. We have to do it every 10 years. Well, as expensive as it is, we could pretty easily check 1,000 people. Or at least it'd be a whole lot easier to check 1,000 people than 320 million, right?
Now the people in America?
Yeah, for about 320 million people in the United States.
How many of them are minorities?
How many are minorities? I honestly don't know that number.
If you were to take a guess.
If I had to take a guess, basically when you say minorities, you mean not non-white, not European ancestry?
Yeah.
I would guess 40, 45%. If I had to guess, I honestly don't know. I'm guessing.
Probably
Okay.
like 55.
So here's our first example. I'm not going to read it, so people watching the video at home, pause the video, read it before we discuss it. So for this problem, let's start by identifying the population. Remember, population is the entire group. So where in this is the entire group that we're looking at? A poll was done to determine how much time the students at this high school spend getting ready each morning. So the students at SDHS, that's our population. It's the only group that we're interested in. Please note, we're not using this to say students, every student in the whole country. We're looking at just this group. So, what is the parameter? Parameter is the thing that we're interested in. It's the number, the data that would be about the entire population. It's very related to the variable of interest. When we measure the variable of interest, we will get a parameter about the population. If we did a census. So, what's your variable of interest? What's the parameter? How much time? Look at that. How much time they spend getting ready is the parameter. There would be an average number of minutes for the entire high school. We have no clue what that average number is. But we would agree that if we were to ask every single person, we could calculate the average number and get the parameter. What was the sample? Yeah, the sample is of the 263 students surveyed. They didn't ask every single person in the school, they asked only these 263 people. So finally, what is the statistic? Remember, a statistic is data that's calculated from the sample. There we go. 61 people said. So in this instance, the population is the SDHS students. Okay, this thing. Take that highlighter. Yeah, the statins. And I'll just switch this over to the green. The parameter. Parameter is the time to get ready.
Do you want us to put like example 1 and all the example numbers?
The sample is the 263 students who were surveyed. And lastly, the statistic, 61. And if we wanted, we could write this as a fraction so that we could start thinking of probabilities. 61 out of 263 spend more than 20 minutes each day. And we're finished. Continuing some of our pieces for vocabulary. Since it is so difficult to conduct a census on the entire population, especially if you have a large population, it's always cheaper and faster to do a sample. Well, one of the things that we are very concerned about is getting a good sample. Because if we don't take and collect data the right way, we'll spend a whole lot of time getting a number, and we can't trust the results of the number. As we saw, bias can be introduced in a number of ways. We saw that you could have a problem with validity, you can have a problem with reliability. If you're just using inaccurate tools, you could have bias. Basically, a biased sample doesn't represent the true population. And one of the things that statisticians have discovered is if you collect data randomly, you can avoid bias. So a lot of what we are going to discuss is how to take the different kinds of a random sample. What are different ways that you can collect data so that you can trust the results? Remember, a random sample is one in which every member of the population has an equal chance of being selected. The most simple one, of course, just pick a name out of a hat. Put all the names in the hat, jumble it up, just pick it out. Bingo is a classic example of randomness. You've got all the balls sitting down in the, I don't know, the bin or whatever it is. You pick it out, they call it out, and keep going.
Are you memorize?
So, if our goal is to get an accurate representation of the population, we have to make a good plan. We have to have a solid plan to make sure that we don't accidentally or even on purpose introduce bias into the data. Here are some good ways of doing it. Obviously, pause the video, read. A simple random sample, and you'll note throughout the rest of it, a simple random sample is going to be abbreviated SRS. Get used to that abbreviation, they use it a lot. A simple random sample is the classic bingo, or the lottery balls for, the ping pong balls for the lottery. Pick a name out of a hat, see what comes up. So, let me get my highlighter. Be larger. That's a simple random sample. When the individuals are selected from one huge list, it's a simple random sample. For instance, take every single person in North Dakota, put them all in one list, put them all in a hat, and pick a name out of a hat, one at a time. But there's one enormous list containing the entire population. That's a simple random sample. Our next technique, or our next sampling method, is called a stratified random sample. You have to keep in mind what the word stratified means. Stratified is grouped. You could almost think of this as a grouped random sample, where we will intentionally pick groups. A good example of this, Ferris's class. That's an intentionally created group. Then we could go Walschlager's class. We can go Charlie's class. Every single class right now is one strata. So trying to emphasize this, the deliberate group is called a strata. A stratified random sample is when you start by creating these groups, and then, and I want to emphasize this, and I want to switch this back to pen. After you pick a strata, every single group gets a simple random sample. For instance, we could go right now and say, take every single teacher's class roster. Those are the strata. We know with this particular class, we have, right now I'm looking in the room and seeing 9 students. If we were to go down to PE, they could have a roster of 20 students. If we go to Ferris's, they could have a roster of 8 students. So not all of the groups have to be the same size. But every single group gets a simple random sample. So we would take the Fry sample, put everybody's name in a hat, and pick out 3 people from Fry's classroom. Then we would go to Walschlager's classroom, pick names out of a hat, and take 3 people from Walschlager. Then we would go to Ferris, take 3 people out of Ferris. And it's not like we're just going in there and saying you, and you. We're doing a simple random where we pick names out of a hat style from every single group. And the groups are created before you ever begin. That makes sense? So process on this one, I want to emphasize it again. A stratified random sample. Step 1, you split everybody into groups. After they are grouped, you take a simple random sample from inside each group. When you follow those 2 stages, you get a stratified random sample. Here's our third good one, a systematic random sample. Okay, a systematic random sample uses a system. That's why it's called systematic. Now, I'm just picking some of the people that I have in the room. I won't use absolutely everybody. But let's say we start with Chance. Chance, I'm going to assign you the number 1. Sammy, you could be assigned number 2. And Nathan, we can assign number 3. Keenan, you'll get number 4. And we can take Alex as 5. Okay, so we'll start right here. You would start off with a list, which is of course what we would do to get a simple random sample. But what we would do, pick a random name out of a hat, and that's where you would start. So let's say we reach into the hat and come up with the numbers. So suppose for a second that number 5 came up first. This is where we would start. Before we started, before we created the list, before we do anything, we would have to describe what system we were going to use. So let's say every third person, since we don't want to do a population sample or a population census, if we want to get 1/3 of the group, we can just go 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And say whoever winds up in group 1, those are the sample. So looking at it this way, we wound up here picking Alex, and so we'd say that's group 1, group 2, group 3. Group 1, group 2, group 3. Group 1, group 2. And so what we wind up with is all the people in group 1 That is our sample. Where everybody has an equal chance, we can still describe the group and say every groups of size, we'll pick 3 groups. Well, suppose chance actually got picked for the starting spot. Then we'd go group 1, group 2, group 3, group 1. Group 2, group 3, group 1. Everybody would still have the same chance of getting selected. It just depends on, do you wind up basically getting selected in that starting position? Something like this is a systematic random sample. In a systematic random sample, you will start by creating the enormous list, the same way that you would do for a simple random sample. You would create the system that you plan to follow. Whether that's every other person, every third person, every 20th person, you create the rule before you do anything. You will do a simple random sample to get your starting value. And once you've got the starting value, all you do is follow the system. You are not allowed to change the system midstream. You're not allowed to alter it in any way. You have to describe the system and follow the system. If you try to change it at all, you are introducing bias into the sample, and we can't trust the results anymore. If you switch the system halfway through, you're lying to the reader. You can't do it. It's not allowed. You have to follow the system. The next one we have is multi-stage random. The key characteristic of a multi-stage random is that there are multiple levels of random selection. For instance, let's suppose you're curious about the average number of kids people have in the United States. Well, the first thing you can do is randomly pick a state. Or maybe you randomly pick 5 states that you're going to look at. Maybe you don't have enough resources to look at all 50 states, so you'll randomly select names out of a hat, 5 states. Well, suppose California, North Dakota, Alaska, Nebraska, and West Virginia get picked. Do you still have enough resources to go ask everyone, all the 56 million people in California? Or the millions of people in Nebraska, North Dakota, Alaska, and West Virginia? Well, if that winds up being, what, 70, 80 million people? I don't even know. If you wind up with 80 million people, can you still do 80 million people? Well, good luck. If you've got enough resources to ask 80 million people, then good job. Because if it takes 12 billion to ask 320 million people, well, if you only ask a quarter, you're still looking at $3 billion to do that survey. Good job. I'm glad you got that money. I don't. So after selecting states, you would then go into another group of selection. Maybe then you would go do a randomly selected county. One county from every single state. So you've got a randomly selected state, followed by a randomly selected county, followed by a randomly selected city, and after having 3 stages of random selection, finally, we start doing a simple random sample from there.
I think this was not much. No, I forgot.
So, in a multi-stage random, we'll do an SRS sample to get subgroups. Then you'll do another one to get a group within the subgroup, and it might be that you would do a group inside a group inside a group, or more. How many stages is irrelevant. It can be 2 stages, it can be 10 stages, it can be a million stages. Although a million stages would be a crazy amount of work. But basically, you're taking a group within a group, and then in that very last step, you will still do a simple random sample of the individuals in the subgroups that got picked. It might wind up that you only have 1 subgroup, it might wind up that you have 5 subgroups, but you do stage after stage after stage, randomly picking groups, and then do a simple random sample from inside those groups. This sampling method is called the random cluster. It is very similar to the stratified random. In both instances, you will start by splitting the population into groups. In both stratified and random cluster, okay, after you split them into groups, you will do a simple random sample to pick what group you're going to look at, or groups. But here is one of the 2 big differences. In a stratified random sample, in the very end, you do a simple random sample on the group. Here, you don't use a sample of the group, you will do a census for the groups that got picked. So here's how it's different. When you use a stratified random sample, you just split people up into groups like freshman, sophomore, junior, senior. When you do a random cluster, you don't split them up into freshman, sophomore, junior, senior. You would do group 1, group 2, group 3, group 4, and the groups themselves would have freshman, sophomore, junior, senior in each group. So group A has all 4 classes, group B has all 4 classes, group C, group D. Every group is a representative sample of everybody. So you split the entire population up into mini subgroups that look like the population already. And then you randomly pick which one of those little subgroups. They're called clusters. You split them up into a representative cluster, randomly select a cluster, and then do a census on the cluster. You see the difference between stratified versus cluster? It's pretty common for students to get them mixed up. The main thing that helps people identify or recognize the difference, a stratified random, in the last stage, you sample the group. In a cluster, you census the group. Right? Those ones that we've looked at are good sampling methods. They're ways of avoiding bias. Unfortunately, you can't always use them. There are 2 bad sampling methods that we should never use because they will always introduce bias. Unfortunately, because of reality, sometimes you're forced to use them because no other way is option. No other way is possible. Remember how we were talking about ethics, where you can't intentionally give people cancer?
I don't know if Dr. Manhattan did it.
Dr. Manhattan is fake. Since you can't intentionally give people cancer to create an experiment, we might be forced to use one of these bad sampling methods. Given that the video is close to 30 minutes, we're going to stop it here, pick up, and continue with the next video.